In our previous video, I explained what random variables are and what they do. In this video, we will explore discrete random variables further. This has some tricky ideas in it, so you may need to pause the video and think as we go through, or watch the video several times. A discrete random variable is the result of a chance event that you can count. Here is an example. Luke has an ice cream stand and sells hand-scooped homemade ice creams in cones. We defined X as the number of ice creams a customer buys. It is a discrete random variable. The distribution for X, the number of ice creams one customer buys, looks like this. In the previous video, we answered some questions using this distribution. We can also find the expected value of X, which is also called the population mean. It gives a long-run average value for all the X values in many repetitions. In our example, it is the average number of ice creams per customer. We calculate the expected value by multiplying each value by its probability and adding the results together. So the expected value for X is 1 times 0.45 plus 2 times 0.34 plus 3 times 0.11 plus 4 times 0.04 plus 5 times 0.04 plus 6 times 0.02. This equals 1.94. In the long run, we would expect the number of ice creams sold to be around 1.94 times the number of customers. You can also calculate the standard deviation of a discrete random variable. Basically, you find the difference between each value and the mean, square it, and multiply it by the probability of that value. Then we add them up to get the variance. The square root of the variance is the standard deviation. There are easier formulas as well. The variance for X, the number of ice creams per customer, is 1.3964, and the standard deviation is 1.1817. The standard deviation is a measure of how spread out the distribution is. We can combine two or more random variables. This is where things get trickier. For example, say Luke has 2 customers left. What is the distribution for the number of ice creams they will want altogether? First, we assume that the 2 orders are independent of each other. We will call the first order X1 and the second order X2. We define Y as X1 plus X2. Then we work out the ways of getting each of the possible values for Y. For example, the probability that the 2 customers will order 2 ice creams altogether is the probability that X1 equals 1 and X2 equals 1. That equals the probability of X1 equals 1 times the probability that X2 equals 1, which equals 0.45 times 0.45 equals 0.2025. The only way they can get 2 ice creams between them is if they order 1 each. The probability that they will order 3 ice creams altogether is the probability that X1 equals 1 times X2 equals 2, plus the probability that X1 equals 2 and X2 equals 1. That equals 0.45 times 0.34 plus 0.34 times 0.45 equals 0.306. You can see that it is quite a long process to work out all the values, though a spreadsheet can make it a bit simpler. This is the distribution of Y equals X1 plus X2. You might like to check that you can get these values. The expected value of Y equals the expected value of X1 plus X2, which equals the expected value of X1 plus the expected value of X2 equals 1.94 plus 1.94, which equals 3.88. The variance for this distribution of 2 customers is variance of Y equals variance of X1 plus X2 equals variance X1 plus variance X2 equals 1.3964 plus 1.3964 equals 2.7928. So the standard deviation for the distribution for 2 customers is the square root of that, which equals 1.6712. This formula assumes that the values of the 2 random variables are independent. In this case, this means that the amount the second customer buys is not affected by the number of ice creams the first customer buys. Sometimes we want to multiply a random variable by a constant value. Say Luke has 1 customer left, but decides to give away 1 free ice cream with each ice cream. In other words, he is going to double each order. What is the distribution for the number of ice creams now, assuming that the customer doesn't change his or her order? We define W as 2x. Here is the distribution. Note that all we have done is multiply each of the values of x by 2. The expected value of W is the expected value of 2x, which is 2 times the expected value of x, equals 2 times 1.94 equals 3.88. The variance of W is the variance of 2x, which is 2 squared times the variance of x, equals 4 times 1.3964 equals 5.5856. The standard deviation of W equals square root of variance of W equals square root of 5.5856 equals 2.3634. We can see that the spread is greater for this distribution than it was for y equals x1 plus x2, even though the expected values are the same. We are more likely to get values further from the mean than we did with the distribution for 2 customers. One way to think about it is that when the 2 independent random variables x1 and x2 were added, it was possible for a high value in one to be balanced out by a low value in the other. This meant that the overall spread was less than simply multiplying the possible values by 2. And here is one last transformation for this video. Say Luke has 1 customer left and gives away 1 free ice cream in addition to the number ordered. What is the distribution for the number of ice creams now, assuming that the customer doesn't change his or her order? We define V as x plus 1. The distribution for V looks like this. The expected value has increased by 1, but the variance and standard deviation have stayed the same. So the expected value of V equals the expected value of x plus 1, which equals the expected value of x plus 1, which equals 1.94 plus 1 equals 2.94. And the variance of V equals the variance of x plus 1, which equals the variance of x. Here is a summary of the formulas we used in this video. We will